Alright, for the standard solution that you want to prepare using dilution method, what you need to know is the number of mole actually remains the same. Only that we add water, right? Or distilled water lah. Okay, the right word is distilled water. So you add distilled water to the amount of volume, the certain amount of volume through calculation. Alright, because when you want to dilute a solution, it is always so that you know what is the concentration you want, but then you do not know how much of initial concentration to use. So meaning that after, let's say you want to prepare a solution, sodium carbonate solution with 0.2 mole per cubic decimeter. So in that sense, if let's say you only have in the lab 1.0 mole per cubic centimeter sodium carbonate. So how much of, let's say at the end, how much of sodium carbonate are you going to initially use to actually produce, alright, to produce for example 0.1 mole per cubic decimeter of sodium carbonate. So meaning that we have to calculate the volume, alright, the volume of sodium carbonate needed initially to produce diluted sodium carbonate. Okay, so let's look at the concept that we have to know. The first thing is to remember concentrated solution means you will have more solute. Solute means in a sense that how much of substance you have inside the solution. Right, if you want to dilute, that means you're adding distilled water. Alright, you want to add some certain amount of distilled water. Alright, so next we have to know the formula for us to calculate. Okay, like I told you that initially you already know, alright, you have the substance, you have the solution. Okay, for this example, you have sodium carbonate in the lab. Okay, you have 0.2 mole per cubic decimeter of sodium carbonate. Alright, of course if you have the volume lah. Only thing you need to know is at the end how much of sodium carbonate you want to produce. So let's say you want to produce for example 100 cubic centimeter of 0.1 mole per cubic decimeter sodium carbonate. Okay, I repeat, you want to produce 100 cubic centimeter of 0.1 mole of 0.1 mole per cubic decimeter of sodium carbonate. That means you want to produce a diluted solution. Okay, the one you already have in the lab, let's say for example you only have 0.2 mole per cubic decimeter of sodium carbonate. So you need to calculate how much of sodium carbonate solution you are actually going to use lah. Alright, you're going to use from the 0.2 mole per cubic decimeter of sodium carbonate. So this is through calculation. You use M1 times V1 equals to M2 times V2. Now why we use M1 V1 M2 V2 is because the concept is to know that the number of mole remains the same. So M is the concentration, V is the volume. So you can use V as cubic centimeter. Alright, because you have already cancelled out the unit, because V on your left and V on your right is the same unit lah. So if you're going to use cm cube, cm cube lah. Alright, so M, remember, is the concentration. So M1 is the concentration, initial concentration of the solution. So M2 will be the concentration of the solution you want to produce. Now V1 is actually what you want to know lah. Alright, V1 is actually how you want to know how much of 0.2 mole per cubic decimeter of sodium carbonate you're actually going to use to produce 100 cubic centimeter of 0.1 mole per cubic decimeter of sodium carbonate solution. So you only need to calculate V1. So to calculate V1, so you use mathematics, transfer M1 to your right. So it becomes M2 times V2 divided by M1. Alright, so here, for example, if I take the question to produce how to prepare. Okay, so here you want to prepare for example, you wish to prepare 500 cubic centimeter of 0.1 mole per cubic centimeter of copper 2 sulfate solution from a stock solution of 2.0 mole per cubic decimeter of copper 2 sulfate using the formula. That means stock solution is the initial solution that you already have lah. So you use M1 V1 equals to M2 V2. Now M1 will be, like I said, your initial stock solution concentration, and you want to find your V1, how much of stock solution you need. So through this calculation, the V1 or the volume that you need is 25 cubic centimeter. Alright, so we take a particular example in your textbook, activity 6.8, page 165. So in this activity, all you need to do is to take the amount of sodium carbonate solution that you have already have. That means you have already prepared in 6.7. Now the sodium carbonate solution that you have already prepared in 6.7 has the concentration of 1 mole per cubic decimeter. So meaning that if you want to prepare for this 6.8, you want to prepare 100 cubic centimeter of 0.2 mole per cubic decimeter of sodium carbonate solution, you need to find out how much of 1.0 mole per cubic decimeter of sodium carbonate you are going to need or you're going to use. So you use the method like I said just now, M1 V1 equals to M2 V2. So like I said, you don't have to change your V to decimeter cube, because if your V is the same in both calculation V1 and V2, you can still use the same unit. Alright, so coming back to the point, so we use the calculation. So in this method, alright, so our M1 is the initial concentration that we already have. So we already have 1.0 mole per cubic decimeter. So 1.0 mole per cubic decimeter is our M1. So our V1 is what we need to calculate lah. Alright, equals to, alright, your M2. M2 will be how much of what's the concentration of the sodium carbonate you want to get. So that means in this case you want to dilute. Alright, you want to dilute 1 mole per cubic decimeter of sodium carbonate to become 0.2 mole per cubic decimeter of sodium carbonate. So in this sense, you must know lah, if let's say you're going to you want to get 100 cubic centimeter of 0.2 mole per cubic decimeter of sodium carbonate from 1.0 mole per cubic decimeter of sodium carbonate. So you need to calculate your V1. So through calculation, you will get your V1. Alright, your V1 will be, right, 1.0. Alright, 1.0 is what you already have, times 1. Let's say for this example, you want to make alright, 100 cubic centimeters. So 1.0 times 100 centimeter cube. Alright, I repeat, 1.0 is your M2. So 1.0 is what you want to produce lah. Alright, so 1.0, alright, times 100 cubic centimeter. Alright, divide. Okay, so your formula will be M2 times V2 divided with M1. So M1 is initial concentration. So your initial concentration is 1.0 lah. Right, so 1, I repeat, so your M2, alright, is 0.2. So your V2 is Alright, 100. So 0.2 times 100, you'll get 20, then divide by 1. 1 is your M1. So in that sense, you will get V1. That means V1 is how much you need, how much of sodium carbonate of, okay, sodium carbonate of 1.0 mole per cubic decimeter you need. So it will be equivalent to 20 cubic centimeter. So how do we actually conduct the process? So the first step, all right, is to pour. All right, so you prepare the solution. The stock solution is your initial sodium carbonate lah. So your initial sodium carbonate of what do you have? So what do you have just now was 1.0 mole per cubic decimeter. So you prepare the solution in a beaker. So that's step 1. Now step 2, after calculation, we already know we need 20 cubic centimeter. So you use a pipette, okay, or you call it pipette. So you pipette out. Use a pipette. Pipette will be apparatus that can measure accurately the volume. So that's why you use pipette, not a measuring cylinder. So once you pipette out, okay, you need to pipette out 20. All right, because you need 20, right? There's no true calculation. You need 20 cubic centimeter of sodium carbonate. So you use a pipette, you pipette out 20. Now, once you pipette it into a volumetric flask. Now, once you pipette into a volumetric flask, all right, now you only have added 20, all right, 20 cubic centimeter of sodium carbonate. So after that, what do you do? So each volumetric flask has a calibration mark. So calibration mark is it shows what is the volume of the solution. So in this sense, you don't use a measuring cylinder at all. So you use a volumetric flask. So let's say the volumetric flask is 100, because now we are preparing 100 cubic centimeter of solution. So your volumetric flask must follow how much of solution you need lah. So in the lab, you have volumetric flask with fixed volume. Okay, if you want 100, 500, but you do not have in between 150 and so on. So you have a standard volumetric flask. All right, once you have added 20 cubic centimeter of sodium carbonate into your volumetric flask, all you need to do next is to add distilled water. Now, when you add distilled water, you do not add till the calibration mark, because we don't want to exceed the calibration mark. So once we exceed, then our solution will not be as what we wanted lah, will be even more dilute, so it won't be accurate. So once we add distilled water, okay, just below the calibration mark lah. So the next step will be using a dropper and to add slowly, all right, distilled water till it reaches the calibration mark. So in that sense, we already come to the last step. The last step will be to use a stopper. All right, so you shake the volumetric flask by inverting, all right, inverting it several times lah. So in this sense, why you need to do that is you need to create a homogeneous solution. So that is the step involved in preparation of a standard solution through dilution method.